Hi, and welcome to On Maths Edexcel Predicted Calculator paper in 2015. This is for Monday's calculator paper, and we have looked at the previous exam, looked at the topics that have come up. We've also looked at what topics come up most often on the Edexcel paper so that you can be prepared for all the usual questions. This paper doesn't obviously go through all of the questions that you will be asked on Monday. But it's a good stab of what's likely to come up for most of the questions, if not some of the questions, hopefully. Now, just before we begin, I will show this graph here. This graph shows what likely grade you'll get for your marks. Just a bit of analysis of where we've got today's paper from. This is a little snapshot of the analysis we put in to look at what questions come up the most. Trial improvement is a massive topic to revise. It's come up almost every calculator paper, and also stratified sampling is likely to come up. I've avoided probability because there were two probability questions, one of which hit national headlines. I don't think tree diagrams will come up, although they could do. And there's a few other topics that aren't probably going to come up. Circle theorems are definitely one I would revise. I haven't included vectors in the predicted paper because the statistics say that it's not as likely as all these ones to come up, but my instincts say vectors are probably worthwhile revising as well. Inequalities did come up before. That's what the G in the fifth column says. They did come up, but they were shading regions, so it's I'm not 100% sure whether they'll come up again, but they're worthwhile revising because they've come up quite a few times on the calculator paper. Pythagoras was also involved in one of the questions in Thursday's exam, but there could be a more basic Pythagoras question in this one. Okay, so let's get started. So question one, I'm going to give you a little bit of time to have a go at it, read the question, maybe try and answer it, and then I'm just going to have the mark scheme come up. So pause the video now and have a go. Okay, right, I hope that went okay. So let's put the mark scheme up. So with this one, it's 30% off, so the first thing to work out is 30% of it. So on your calculator you do 30 over 100, because percent means per 100, cent being the French for 100. So you do 30 over 100 and you times it by 360. That gives 180, but that's how much money she has off. So you then have to do £360, take away the 108. I believe it should say equals 108 on that first line of working out. But take away 108 and you get 252. Now that's how much money that it cost, but she used a voucher for £200, so you've got to then deduct the money that she saved using that voucher. So you do 252, take away 200 and you're left with 52, and that's 4 marks. Okay, question 2. So exchange rates, which are likely to come up. Pause the video now and have a go. Okay, so with this one, like a lot of exchange rate questions, there's a part of the question where you've got to work one way and a part of the question you've got to work the other way. So she buys the euros for £1 equaling 1.15 euros. So when she has £600 that she's buying, it means that you have to do 600 times 1.15, and that's the first mark. If you get 690, you get another mark. But he spent 570 euros on holiday. So you've got to work out how much he had left. So 690 take away 570 gives you the 120 euros that he has left. Then the exchange rate when he sells them is £1 to 1.29 euros. Now when you're working the other way with exchange rates, you are dividing. So you divide the 120 euros by 1.29. You get 93.02 blah 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 blah, and you always round money to 2 decimal places unless it states otherwise. Okay, So question 3, pause the video now and have a go. Okay, let's have a look at the answers. So with this one, you've got to see how much buns the recipe's for, which is 20, and how many you need to make, well 30. Now the way I'd look at this question is I'd think, right, well if I halve all of these it makes 10 buns, and if I times that by 3 it will make 30. The way they've done it is worked out the proportion between 30 and 20. They've done 30 divided by 20 and found out that you need to times all these by 1.5. So they've gone through all of them and times them by 1.5. The answers are 270, 225, 300 and 6. And there's loads of different ways of doing this, but as long as you've got those answers you're fine. So question 4, pause the video now and have a go. Now, common mistake with this one is not reading the question. Okay, there's loads of information in this question, but Jen has a trim and colour, which is just this one, and she gets 15% off. So you just need to work out 15% of that and take it away from £65.50. So to do that, you can do it one of a number of ways. You can work out 10% of that by dividing by 10, work out 5% by halving it, and then add those two together. Or you can do 15 divided by 100 like we did before, 0.15, and times it by 65.5, and you get 9.825. Now you've then got to do £65.50, take away that £9.83. When you do that, you get somewhere in one of £55.67 or £55.68, and they're quite lenient sometimes. And make sure again that any money is to 2 decimal places. Okay, question 5. Pause the video now and have a go. Okay, there's definitely a trick to this question. There's a button on the scientific calculator which makes fractions, and that makes this question, these sort of questions, so much easier. It's a little square and then there's a fraction line and another little square. If you press that, and you can just fill in that this expression or this calculation here straight into your calculator and just press equals. Now when I was running through this exam paper with my students today, there was a lot of students mistyping some of these numbers, so make sure you check it. Most calculators you can check it on the calculator without having to scroll. Make sure you check it before you press equals. And when you do that you get 6.79056 blah blah blah. On most of these questions, if you've got 7 digits written down at least, you don't have to write down any more than that. I say to my students that as long as you write down everything that's on your calculator display without scrolling, you're fine. Don't ever scroll through, because some of them it goes on for a very, very long time. Then a suitable degree of accuracy, I normally use 2 decimal places, and I think Edexcel like 2 decimal places or 3 significant figures. Here they've been a bit more conservative and just done either a 7, which is 1 significant figure, or 6.8, which is 2 significant figures. It's very rare that you're asked to come up with a degree of accuracy. Normally 2 decimal places is good enough. Okay, question 6. Pause the video now and have a go. Okay, with this one it's a simple Pythagoras question. As I said, this did come up as part of a question on the Thursday's paper, but it didn't come up as an isolated question, so it might still come up. Now with Pythagoras it's a squared plus b squared equals c squared, or some of you might know it as 3 steps. First step is to square them, second step to add or subtract them, and third step to square root them. So basically 15 squared and 7 squared, that makes 225 and 49. And then when you've done that, you add them, you take them away because you are not finding the hypotenuse. So you do 225 take away 49 and then square root it. and the answer you should get is 13.26 or 13.3. Question 7. Pause the video now and have a go. Okay, there's two ways of doing this one. I always say when solving equations, get rid of brackets and get rid of fractions. On this one we've got a set of brackets we need to get rid of. Now this 4 here means we're timesing everything in the brackets by 4. So to get rid of that we can divide both sides by 4. So just do 20 divided by 4, which is 5. So it's 3x minus 7 equals 5, and then solve it from there. Or you could expand these brackets, so 4 times 3x is 12x, and 4 times minus 7 is minus 28. So the method is here, and they've worked it out, and they've got the answer of 4. Okay, question 8. Pause the video now and have a go. Okay, this trial improvement will come up, absolutely will come up, unless I'm thinking back about 5 years where we were convinced it would come up and it didn't come up at all, but most years it does. So with this one, it will normally give you a hint of what sort of value to be looking at, and it's given the value of 3 here, and it's saying it's too small. So a sensible one to try next is 4. If you try 4, you'll find out it's too big and it will trap it between 3 and 4. Then you go to 1 decimal place and try 3.5, 3.4, etc, etc. When you have 2 that it's trapped between, on this question is 3.8 and 3.9, the important last step is to try the middle number. Now if you think about it on a number line, 3.8 being this side and 3.9 being this side, to know which one it will round to is which one it will be closer to. So if it's closer to 3.8, it will round to 3.8, and the answer will be 3.8 to 1 decimal place. But the line at which the cutoff line, which tells us to round between 3.8 and 3.9, is 3.85. It's the halfway point between those values. So if 3.85 is too small, it would round to 3.9. If 3.85 is too high, then it will round to 3.8. And when you do that, you work out the fact that it rounds to 3.8 because the answer it gives you is too high. It gives you, what is it here, 45.5, which is too high. Okay. Question 9. Pause the video now and have a go. Okay, question 9 is about sequences, which didn't come up on the non-calculator, so it's quite likely to come up on the calculator. The important thing to look at in this question is not the actual patterns themselves, although it can be useful. It's these numbers, 4, 7, 10. When you're finding out the nth term, you need to find out what it goes up in. So 4, 7, 10, that's going up in 3. Whatever number is going up in, put before the letter n. So for this one, 3n. But 3n would just give us the 3 times table, 3, 6, 9, 12. This isn't the 3 times table. So you work out how to get from 3, that you have before the n, 3, to 4. And I know I need to add 1. So the answer is 3n plus 1. Now for the next question, it says explain why there is not, why there will not be a pattern which uses 146 matchsticks. There are quite a few ways of doing this. I've had students before just writing the whole thing out because they've got some time left in the exam. That normally is good enough proof if you write out the sequence up until that point, but there are better ways. If you get 3n plus 1 and equal it to 146 and then solve it, if you get a whole number as an answer, because n must be a whole number, then 146 is in the sequence. If, however, you get a decimal or a fraction as an answer, it means that 146 is not in the sequence. And looking at the answers here, it looks like it's not, because it's not an integer. Integer just means whole number. Question 10. Pause the video now and have a go. Okay, so inequalities did come up on the last paper, but it was graphical inequalities, so they could be asking about basic inequalities. To solve this one, you just pretend but don't write that that's an equal sign. Okay, so you solve that the way you would solve if that was an equals there. What a problem I've had in the past is students will draw an equals. Don't ever put an equals there. Now there is one thing you need to remember. First of all, if that was an equals, if you swap these around, that would be fine. If you swap the 16 and the 3x minus 5, if you swap the sides, you must make sure that points the other way. And if you times everything by minus 1, then you need to switch this around. Okay? You don't need to do that for that question. So with this, I'd add 5 to both sides and then divide by 3 to both sides. And I get the answer of x is greater than or equal to 7. With this one, it says write the integer values that satisfy this diagram. Integer just means whole numbers. If you didn't have the word integer there, you'd be there all day. 1.1, 1.11, 1.12, 1.13, and then you could get even more detail than that. 1.00001, blah blah blah. Okay, it's infinite. This dot here is filled in, which means that it includes the 1. This dot here is hollow, which means it doesn't include the 7. So 1, 2, 3, 4, 5, 6, but not 7. And that gives you the 2 marks. Question 11. Pause the video now and have a go. Okay, so this is ratio and a bit of percentages in this question. So he's paid £250 a week, and he shows his pay in the ratio of 3 to 2 with his sister. And then he saves 12% of the share. So the first thing to deal with is the ratio. And there's 3 steps to a ratio. The first thing is you add the parts together, or you add the 2 sides together. So in total there are 3 plus 2, which is 5 parts. Second step is you get the amount, £250, you divide it by that 5. Okay, so 250 divided by 5 is 50. So that means each of these parts, the 3 parts on the left hand side and the 2 parts on the right hand side, is worth 50. Now we're only dealing with what he gets, and it says he shares his pay with his sister, so his pay is this 3 here. So we need to know how much he gets, so it's 3 parts and each part worth 50. 3 times 50, 150. So £150, but he only saves 12% of his share. Well, with a calculator we do 12 over 100 and times it by 50. So when we do that, 0.12, which is 12 over 100, times 150, we've also got to realise that it says how many weeks would it take Andrew to save £360. Now to do that, you get the amount, the answer you get there, and you want to do 360 divided by that answer. Find out how many 360s there are in that. So 360, I think in this question is 18. So 360 divided by 18, because he's getting £18 that he's saving a week, and it will take 20 weeks. Question 2. Pause the video now and have a go. Okay, I have a strong feeling that finding the mean, maybe the modal class, and sometimes the median from a group frequency table will probably come up. So we're looking at mean. They've given you a little bit of a hint here by adding another couple of columns, which I'll show you here, which means that you'll probably need to use them, and for most of you it will be a bit of a hint. This column here is for midpoint. 0 to 10, the midpoint is 5. 10 to 20, the midpoint is 15. If you don't know how to do midpoint, it's just the halfway point between 10 and 20. If you're really stuck, there's a way of doing it. For any numbers, you add them together, which is 30, and then halve it, which is 15. Most of you will just look at that and know it's 15, 25, 35, 45. So you fill that column in. The next step is to do the midpoint times the frequency. So 5 for the midpoint times 5 for the frequency, so 25. 15 times 22. 25 times 28, etc, etc. Then you need to get a number here, which is the total, the sum of this column, sum of frequencies, and a total here, which is the sum of the fx, or sum of this column here. then you need to swap them around the other way and put a divide sign in the middle. Okay, and if you follow those steps, you get the answer 24.6. Now for the second part, it says 70% of the patients wait less than 30 minutes to be seen. Is she correct? So you first of all got to work out how many patients wait less than 30 minutes. So it's this one, and this one all describe patients that are waiting less than 30 minutes. So it's 28 plus 22 plus 5, which is 55. But that doesn't give us a percentage. We need to know how many there are in total. So you add these up in total, and I think there's 80, where it tells us in the question that it's 80. So you do 55 over 80, 55 divided by 80. But that gives us a decimal, or a fraction, but it doesn't give us a percentage. To make that percentage, we times by 100. And when you do that, you get 68 point something or other, or 69 rounded. But it says here 70% of the patients wait less than that. Is she correct? So it will be no, she's not correct, because 69 do. Question 13. Pause the video now and have a go. Okay, all this question is testing you on is whether you know or remember what a frequency polygon is. Frequency polygon is not a bar chart, and a lot of people like drawing bar charts. Even high ability students do, because they think that this might be a histogram. Frequency polygons are little crosses at the midpoints of each of these groups. So looking at this first one, 20 to 30, the midpoint would be 25. So down here, between 20 and 30, I'd put as 25, and it would be 4 high, so I put a little cross there. Then an 8 at 35, so up here. Then a 17 at 45, so 17 and 45 would be up here. And then 12 at 55, so 55, 12 there. Then when you finish that, you'll have 4 points, and you just join them all up with straight lines. Do not make a polygon. Just join them up from left to right, 1, 2, 3, and stop. Some students then join up to make a, well, this one would make a pentagon. Right? You don't need to do that. In fact, sometimes you lose marks if you do that. Okay, so that's the mark scheme for this. So question 14. I realised that transformations did come up, but translations and enlargements aren't involved in this predicted paper, although again I would heavily recommend you revise negative scale factors and fractional scale factors for enlargements, especially if you're looking for an A grade. But translations also didn't come up, so I thought it might be a sneaky one. Pause the video now and have a go. Okay, for translations, the most important thing you realise is the top one is how far right and the bottom one is how far up. If you want to move left, you make this a minus. If you want to move down, you make this a minus. So this is telling us to move 2 right and 3 up. So you start here, and you can draw little jumps. So 1 jump, 2 jumps right, and 1, 2, 3 up. So that point there goes that point there. And you put a little cross. Now some of you will realise that you can draw the shape in instantly, and cross there and up there, just copy the shape in. But it's really important that when you copy the shape in, that it's the bottom right one that you're putting here, that you don't draw the shape in down here somewhere. Okay. So just moving it 2 squares right and 3 up gives you both marks. Question 15, pause the video now and have a go. Okay, this is quite a basic expanding one. I do it as smiles and rainbows, but some of you do it in grids, and there's loads of different other strategies. You basically are doing 2 times A, which is 2A, 2 times 3, which is 6, 5 times A, which is 5A, 5 times minus 1, which is minus 5. And then you add the 2A and the 5A together, 7A. then you add the 6 and the minus 5 together, which gives you 1. Question 16, pause the video now and have a go. Okay, circles did not come up at all on the Thursday's exam. Now it's not surprising because they use pi, which normally you need to use a calculator for, but there's either going to be a question on circle area or circle perimeter. They normally put it as part of a more difficult question rather than just having a circle and asking you to find the area or circumference. So this is my more difficult question, although it's not that tricky. It's a full circle inside a semicircle, and looking at this, the semicircle has a diameter of 10. Now, because it fits exactly in it, this here is both the diameter of the bit full circle, the small full circle, and the radius of the big semicircle. The radius of the big semicircle, so the big one here, is 5. So therefore the diameter of this circle here is going to be 5. So when you're working out the areas, you do pi r squared. So for the big semicircle, it will be 5 squared times pi, or pi times 5 squared. And for the smaller full circle, it would be 2.5 squared times pi, or pi times 2.5 squared. Don't forget when you're working with the area of the big semicircle that you need to halve the area. So you need to do the area of the semicircle, take away the area of the circle. Okay, the area of the big one, take away the area of the smaller shape. And here's the pi times 5 squared, and then divide by 2 because it's a semicircle. And then you're taking away 2.5 squared and obviously timesing that by pi. So you get the answer of 16.6. Question 17. Pause the video now and have a go. Okay, so cumulative frequency did come up, but they shied away from box plots, so it could still come up. The first question just asks you to draw a box plot, and it gives you the 5 values. The 5 values I'll show you on this one. This is the smallest value, or slowest time, or smallest value. This one is the lower quartile, this one's the median, this one's the upper quartile, and this one's the highest value. So looking at these, the smallest value is 14, so that point there will be at 14. The lower quartile is 18, okay, etc, etc. Now, whenever you're comparing box plots, you must compare 2 things. You must compare the medians, and you must compare the ranges. Now, the medians are quite easy to compare. You state what the medians are and say, this one's higher than this one. Now look at this, the median of this one was 24, median of this one's 20. So you say the median on average, these guys are faster, or whatever the question's on about, or these ones would be faster, okay, being a smaller value because we're looking at how quick they were. And the second thing you need to compare is the range. Now you can either do the range, which is the biggest take away the smallest, or you can do the interquartile range, which is the upper quartile, take away the lower quartile. But whenever you're asked to compare 2 box plots, it must be those 2 things that you compare, the median and the interquartile range, or the range. So question 18, pause the video now and have a go. Okay, so standard form normally comes up in the non-calculated paper, but it has come up in the calculated paper semi-often on the Edexcel. It makes it a bit easier to work out because you don't need to use the tricks that you do with the non-calculator standard form questions. So for this one, you just need to type it into your calculator and see what number you get. When you do that, you get the number 1612.5, but it says you write your answer in standard form. So to do that, you look at where the decimal point is and you count how many jumps you need to make until the full number is between 1 and 10, not including 10. So the decimal point will end up here. So it'll end up with being 1.6125 times 10 to the power of however many jumps left you had to do. So I had to do 1, 2, 3 jumps left. So it's 10 to the power of 3. Now with this one, it's going backwards through a number machine, okay, or a function machine, or there's loads of different words for them. When you go forwards, you take away 1,000 and divide by 20. But when we're going backwards, we're going to get this number into our calculator, times by 20 and add 1,000. When you finish that, you get 102,000. Now with this one, the decimal point is always at the end if it's not shown. So it's always here. So again, I'm going to jump until I get a number between 1 and 10. So 1, 2, 3, 4, 5. So I've had to do 5 jumps, so it would be times 10 to the power of 5, and the answer will be 1.02 times 10 to the power of 5. You don't need to do 1.02000 because those zeros aren't placeholders, they can just go away. Question 19, pause the video now and have a go. Okay, this goes with what I said earlier, that you always must get rid of brackets or fractions. So here we have, well, when solving, here we have a fraction. Now what this means is 18 plus 5x, all of that divided by 3. So to get rid of that, I need to do the opposite of it. So if that's a divide by 3, I need to times both sides by 3 to get rid of that. On the left hand side, I'll finish with 18 plus 5x, and don't times that by 3 because we've already done that by removing the divide by 3. And here, I can either put this in brackets and put a 3 before it, or I can just times the 10 by 3 and times the minus 1x by 3. That gives me 30 take away 3x. Then when you've done that, and I'll show you down here, you end up with x's on both sides. Look at which side has the least amount of x's, which is this one, and get rid of that. So minus 3x, I'm going to get rid of that by adding 3x. So that makes that 8x. Then I'm going to get rid of this 18 by taking away 18 to both sides, and that gives me 30 take away 18, which is 12. So 8x equals 12, and when you do that, you then divide by 8 to get rid of the 8 on the 8x, which gives me 1.5, or 3 over 2, or 1.5. Question 20. Pause the video now and have a go. Okay, question 20, again, likely to come up. Trigonometry questions will come up as a certainty. It's just what type of trigonometry questions. We've got a basic one in A and a slightly harder one in B. A is the basic SOHCAHTOA, so first of all label the sides. This one's the hypotenuse, which isn't used, so you don't need to label it. This one's opposite because it's opposite the angle, and this one is the adjacent because it's next to the angle and the right angle. Knowing SOHCAHTOA, I recognise the fact that I've got O and A, which means I'm using tan, and some of you will write tan x equals O over A, and some of you use the triangles. Each method will work. When you do that, you get the answer of 30 or 30.3, or anywhere in between those two. When you do that, you get tan x equals 7 over 12, which is 7 over 12, and you need to inverse tan both sides, so it's x equals the inverse of tan, which when you press shift and tan, 7 over 12. Now with this next question, you need to recognise whether this is the cosine rule or the sine rule. It's asked us for length BC, which is here, and when you've got a length opposite an angle and another length opposite an angle, with one of them being unknown, it's always going to be sine rule. And sometimes you're given this angle down here, but you can work out what this angle is by doing angles in a triangle add up to 180. This one you don't have to do that, it's set out nicely for you to recognise this as a sine rule. It is given to you, the formula, on the front page of the exam. As soon as you open the exam on the formula booklet, it tells you how to work this out. It even draws a little triangle telling you what big A and little a are. So with this one we're looking for a side. So the formula I use is A over sine A, or big A, equals b over sine b, being a big B. When you put in the values you know, it even tells you where big A is. So it will be x, I call it x if I don't know it, over sine 40 equals 18 over sine 110. And you do 18 divided by sine 110 and find out what that is, and then you times it by the sine 40 because you're going to times both sides by sine 40 to get x on its own. When you do that, you get 12.3 something. Question 21. Pause the video now and have a go. Right, with this one, stratified sampling, it's very likely to come up, so it's worthwhile learning if you didn't know it already. With stratified sampling, the point is with it, if you imagine a school has almost all girls, but it has 10 boys in it, and they're looking at getting rid of the girls' toilets in the school. Now, if you imagine that they took a sample of 10, and all 10 of those happen to be those 10 boys, what are those boys likely to say? They'll probably say, yeah, let's get rid of the girls' toilets. The point of stratified sampling is if you've got more girls or more of one type of person than anyone else, that they get more of a say in the sample, which is only fair. So here, looking at this, most people are male and 18 to 65, so they're going to be the ones that are asked the most. There's very few females who are over 65, so they'll be asked the fewest. Now, there's a mathematical way of doing this. It's not that difficult. It really is not. The first step to know is what all of these add up to, which it tells us here, 746 patients. The next thing to know is what sample size you want. Well, it says here it's 80. And then you just go through it by doing what fraction is that 84 of the population. So it's 84 divided by the total amount of people. So 84 divided by 746. But that will give me a decimal, and we're looking for an amount of people. So we then times that by 80 and gives me the answer there. Make sure you round it to the nearest integer because we don't want half a person. Then 342 divided by 746 and then times by the 80. It gives us an answer here. When you do that, you get 9, 37, 5, 4, 21 and 4. So this one here, we knew we wanted to ask the most, so we've asked 37 of them. And here we wanted the fewest. Well, it's joint fewest because there's not much difference between 37 and 39 at 4. So it seems to make sense. The last step, sometimes, very rarely, these don't add up to 80, and that's okay. Sometimes they'll add up to 81. If they do add up to 81, have a look back at which one you rounded up. And so if you had one that was 4.5, if that was 4.5 and you rounded it up to 5, if it adds up to 81, then just round it down. So just move that to a 4. So see which one of these you can actually just shift the other way slightly. It's very rare that they don't add up to the 80, but just in case. Okay, question 22. Pause the video now and have a go. Okay, so with this one, it's powers, which sort of did come up a little bit on that paper, but we didn't have brackets involved. When brackets are involved, you've got the number on the outside and 3 things on the inside. The reason I say 3 things is you must treat them separately, so deal with them separately. Any numbers you have, just put to that power. So 2 to the power of 4, well 2 times 2 is 4, times 2 is 8, times 2 is 16. So just write the answer 16 to start us off. Then a to the power of 1. Okay, we don't write the 1, but there is a 1 there. And the rule is you times it by what numbers on the outside, what powers on the outside. So 1 times 4 is 4. So it would be 16a to the power of 4. And b, well, this is to the power of 3. So times that by 4 and you get 12. So the answer is 16a to the power of 4, b to the power of 12. Question 3. Pause the video now and have a go. Okay, histograms are very likely to come up. They either will be asking you to draw a histogram or interpret a histogram. I don't have a question on interpreting histograms, but if you have some time this weekend to have a look at that, then that would definitely be worth having a look at if you're looking for an A or an A star. With this, you just need to know what the heck a histogram is. The common problem with this is students just fill in the frequencies onto this graph. This is for frequency density, and you need to know how to work out frequency density. You need to add two columns to this, although some people miss the middle one. You need to know what the class width is, and then you need to know what the frequency densities are. The class width is just the width of the class. It is the bigger number, take away the smaller number. And again, most of you will just be able to see it. This first one's 10. So for this first one, I'll get the 17, and I add the 10 there. So how would I work out frequency densities? Well, you just do frequency divided by class width. And for those who use triangles, with the speed, distance, time triangle with distance at the top, frequency will be at the top of this triangle. So 17 divided by 10, which is 1.7. And I already think, well, hang on, the scale here, that fits nicely. I'm probably getting it right. If that's 1.7, then all I'm drawing is I use the word bar chart, although with a bar chart you should have gaps between them without a continuous x-axis, but it sort of looks like a bar chart without the gaps. And it's just a box that is 0 to 10 and it goes up to 1.7. The next one, I think the common wrong answer for this is to put 1.2, and I understand why. They think if that's 10, that's going to be 10. But if you look at it, it's 10 to 15, not 10 to 20. 15 take away 10 is 5, so the class width is 5. So it's 12 divided by 5. This one is 15, so 3 divided by 15. And this one is 30, so 9 divided by 30. So the correct frequency density is 1.7, 2.4, 0.2 and 0.3. And then when you plot them and draw them nicely, you get the 3 marks for a fully correct histogram. Question 24. Pause the video now and have a go. Okay, I think most of you will be able to identify the fact that this is a reverse percentages question. It's done something in the past and told you the value that it is now, but it wants you to work out what the value it was before. Now, if you are trying to do this question, if you're sort of looking for B, A star grade, you know probably by now the multiplier method of using percentages. To do a multiplier, you start off with 100, always 100%, and you figure out what you're going to be doing. So it says decreases by 15%. So I want to take away 15 from that 100, and I get 85. But then I divide that by 100 to get it as a decimal, so 0.85. So I know if I was to do this question, if I had the starting figure, I would times it by 0.85 for the first year, then times it by 0.85 again for the second year. But it's given us the value of the TV, I think it is, TV now, not what it was before. So instead of timesing by 0.85, I'm going to divide by 0.85 and then divide by 0.85 again. And the answer you get is 600. Now you can check that by timesing by 0.85 and times it by 0.85, and you should get the number in the question. You could also divide by 0.85 squared. Instead of divided by 0.85, then divided by 0.85. It doesn't matter. Question 25. Pause the video now and have a go. Okay, so this is a very similar question to the last question, which is why I put them together. This is compound interest, and using the multiplier method, I start off with 100 and I add 4, so I end up with 104. Then I divide that by 100 and it would be 1.04. And I've started with 1,800 and I just want to keep going until I get to 2,000. Now, £2,000. I would recommend you just keep going until you get to that. There are other ways of doing it, and if you do know other ways of doing it, then fine. Because I can get to 2000, I reckon, pretty quickly. I would just keep timesing this by 1.04 until I get to 2000 and just count how many times it took. So I think it ends up being quite a small value. There are 3. So if you times it by 1.04, then times it by 1.04 again, and then times it by 1.04 again, then I eventually get over 2000. So it'll be worth, more than £2,000. Question 26. Pause the video now and have a go. Okay, circle theorems will come up. I always am surprised with a few topics I absolutely feel will come up that don't. But I really do feel circle theorems are very likely to come up. I've picked as difficult question as I can so that it reminds you of some of the lesser thought about circle theorems. So it says work out the value of x. Now x is here. So whenever I have a tangent hitting a circle, there are 2 main circle theorems that come to my mind. The first one is the angle between a radius and a tangent is 90 degrees. Which on this one we don't have a radius, so that's useless. And the second one is 3 words you need to know off by heart if you want to get an A grade. The 3 words are alternate segment theorem. Now any revision guide or textbook will have a nice diagram of this. It just is a triangle coming from a tangent. And with this it's really weird. It's this angle here, which is between the tangent and the triangle. It's equal to the sort of opposite corner of the triangle. So x therefore is 64, and all the reason it is those 3 words. All the mark schemes will only use those 3 words. No other explaining and saying, oh well, this will be equal to that and that will be equal to that, whatever, is going to give you the marks. It's just those 3 words. Now to get y, I noticed that there's a cyclic quadrilateral going on. There's 4 corners of a quadrilateral touching the circle, and that's 83. Now a common mistake is, well, if that's 83, that's 83. That's not how cyclic quadrilaterals work. Opposite corners of a cyclic quadrilateral add up to 180 degrees, so I need to take that away from 180. So the answer is 97. Now it looks like on this exam you get away with not using the word theorem, so alternate segment seems to be enough, but just remember those 3 words. And also cyclic quadrilateral and all the other explanations. Angle at the centre is twice the angle at the circumference. Angles on the same arc are equal, blah 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 blah. Try and remember the reasons why as well as what the circle theorems are. Okay, question 27. Pause the video now and have a go. Okay, this will either be a question about linear graphs or quadratic graphs and drawing them. You may have to draw the graph yourself like you've had to on this question, or the graph may be drawn for you. The first thing about this question is you have a calculator and you can just use your calculator to work out each of these. Now with 2 it's quite easy, 2 times 2 squared minus 3. With 0 it's even easier, 2 times 0 squared, it doesn't matter, it's 0, and then take away 3, so that would be minus 3. This one's the one that causes the most problems, and there's a reason why they normally do negative values, because they know it does cause problems. On your calculator, just do this question as you would with the 2, but instead of just writing minus 1, just put it in brackets. So 2 times brackets minus 1, close brackets, squared, take away 3. If you don't put it in brackets, then most times people just write minus 1 squared. The calculator will follow BIDMAS and square the 1 on its own, not the minus 1, and then put a minus before it. So just be careful of that. Anytime you put a negative number into expression, make sure you put brackets around it. When you do this, you get minus 1, minus 3 and 5, and you just need to draw the graph, and so the x-axis is between minus 2 and 2, the y-axis is between 5 and minus 3, so 5 up here to minus 3, Make sure the gaps between each of them are equal. I think on this one you can use either 5 or 10 squares for the gaps. Okay, and when you plot it, so you plot the graph, you'll find out it's a U-shape. And it's either a U-shape for quadratics or an upside down U-shape. And I find it easier if I turn the page on its side to draw the U. I find this more difficult than this. So just doing it sideways, I find it a lot easier. Make sure the line goes through all the points. And if there's 2 points at the bottom that are the same height, at the bottom of the U, make sure your U goes below them, because there were quite a few people lost marks on a previous exam where they didn't make the line go below those 2 points. Question 28, pause the video now and have a go. Okay, so in the last paper you had to expand surds, but you didn't have to expand quadratics. Now this one's quite a tricky expanding question because there's 2 variables, but you work it out the same way. Now I'm not going to go through any strategies. Some of you use foils, some use the grid method, some of you use smiley face or double smile and rainbow, or there's whole hundreds of different ways that your teachers may have asked you to do it. You've just got to times each of these by each of these. Okay, so 3x times 2x is 6x squared, 3x times minus 5y is minus 15xy, etc, etc. And when you've done the first round, you realise there's 2xy terms, there's minus 15xy and plus 2xy, and you just need to add those together, which makes minus 13xy. So that's the answer there. Okay, question 29. Pause the video now and have a go. Okay, with quadratics, to find solutions or roots, it's if you draw the quadratic, it's basically that when you solve it, it's where it hits the x-axis. Now there's either 2 solutions, like the previous question we had. There could be 1 solution if it skimmed the line and only touched it at 1 point, or there could be no solutions if the graph doesn't touch the x-axis at all. You don't need to know any of that, but it's useful for the A-star grade questions on this. With this, if you have solving quadratics and it says give your answer to 2 decimal places, it's basically giving you a hint that you can't factorise it and solve it. So we've got to use the quadratic formula. The quadratic formula from memory is minus b plus minus square root of b squared minus 4ac over 2a, I hope. And what some people do is just plug it into the calculator and let the calculator do all of the work for them. Now there's a couple of things to go through. First of all, you need to know what a, b and c are. A is the number before the x squared, b is the number before the x, and c is the number on its own at the end. Now, common mistake, a equals 6, b equals 2, c equals 5. No, c does not equal 5. C has to equal minus 5, and don't forget that. Also, if you're plugging it into your calculator, just into the formula on your calculator, remember to put brackets around any negative numbers. So you would put brackets around the minus 5. Now, some of you are thinking, who probably haven't done a quadratic formula, why is there a plus minus? That plus minus enables us to have 2 answers, because we know that normally on these questions you'll get 2 answers. It even gives you a hint here. It says give your answers to 2 decimal places. So it hints to you that there's more than one answer. So you'll do you'll do the quadratic formula with a plus and then do it with a minus and write down both answers. Now some of you are thinking, I'm not quite sure I can remember the quadratic formula. It's in your formula book, right, or formula page right at the front of your exam paper, so you don't need to remember it. You can turn up on the day. If you have 5-10 minutes left of the exam but you've never done quadratic formula, you could probably get a few marks just by working out from the first page of the exam. So there's the formula there, and they've put brackets around all the numbers there, which is probably a good idea. But the best idea is to make sure that they're around the negative numbers, and they've got 2 answers there. One's a positive and one's a negative. Okay, question 30. Pause the video now and have a go. Okay, so simplifying algebraic fractions. With this, you need to get a bracket at the top and a bracket at the bottom that are the same that you can cross out. Now, x squared and minus 16, it doesn't look like you can factorise that unless you know about the difference of two squares. The difference of two squares, which is in any revision guide or textbook, tells you that if you have this situation where you've got a square to take away another square number, you can put a set of two brackets down, with one of the brackets being x, which is the square root of x squared, minus 4, which is the square root of 16, and then another set of brackets with x plus 4. So the top bit there is x minus 4 and x plus 4. When you factorise the bottom, and again there's loads of methods to factorise that, when you factorise the bottom you're expecting one of them to be either x plus 4 or x minus 4, and that gives you a hint of how to factorise that. When you factorise the bottom, look at the answers, you get 2x plus 3 and x minus 4. So again, we can see the x minus 4 is the same at the top. And then you cross out the x minus 4 at the top and bottom, and we're left with x plus 4 over 2x plus 3. And that's the answer. Question 31. Pause the video now and have a go. Okay, these bounds questions frustrate people because they think, hey, what do you mean the maximum? There's only two values there. Well, yeah, with bounds there aren't just two values there. That 1,500 kilograms is actually multiple values because we don't know what that was before it was rounded. It was rounded to the nearest 10 kilograms, so the minimum that could have been is 5 kilograms less, and the maximum that could have been is 5 kilograms more. Now you might think, hang on, it can't be 5 kilograms more, surely it would be 4.9 recurring kilograms more. Well, 4.9 recurring is the same as 5, so don't bother putting 4.49 recurring of anything or 4.9 recurring of anything. Always just have 5 less and 5 more. This is the nearest kilogram, so that could be half a kilogram less or half a kilogram more. So there's the methods there, and that goes through the calculations in a little bit more detail, but that's the main thing missing. And if you look here, it doesn't matter if it's 0.49 recurring or 0.5 or 4.9 recurring or 5. In fact, it's preferable when you're doing calculations not to have 0.9 recurring at all, so it makes it a lot easier to work it out. And they've worked out the answer to be 19.8 or 19. If you have a look at this question, it says work out estimate of the number of soldiers. So that was actually worth a mark to round that to the nearest whole person. Now this goes back to the sampling question, the stratified sampling question, where you had to round them to the nearest whole person. This is also a question that it doesn't make sense to have 19.8 of the soldier. We can't round that up to 20 because then they'd be over the limit, so it would round down to 19. Question 32. Pause the video now and have a go. Okay, there will probably be a simultaneous equation question. I've gone for a quadratic one, but it could be a linear one, so you might want to revise that as well. With the quadratic ones, you don't try and get one of the numbers the same and do all that method. With this, it's a matter of substitution. One of the equations will be very simple, and sometimes it's just y equals x plus 3 or something, and one of them will be more complicated. So with this one, we need to work out what x is, or what y is. So add x to both sides, that becomes y equals 2 plus x, and that gives me what y is. So I could substitute in the 2 plus x there and then solve it. Or you could find out what y is. So if you add x and then take away 2, you then get x equals y minus 2, and then substitute in that there. I would probably go with the first method. So they've written y equals 2 plus x, and they've put in the 2 plus x there, and then they've moved the 2 and the x across by taking away 2 and taking away x to both sides, and they've used the quadratic formula again, which I'm not going to go through again because I've gone through that before. Okay, and that is it. Thank you very much for listening, and the best of luck for Monday's exam. Thank you.